In this video, I have some tips for the last 4 edges stage of your 6x6 and 7x7. Hi guys, I'm going to discuss in this video how to improve the speed of solving your last 4 edges, and it's not going to be particularly prescriptive. It's just going to be kind of a general toolkit of things you can use and apply for your last 4 edges on your 6x6 and 7x7. So in the beginner module, I discussed solving the inner 2 wings on a 6x6 and the inner 3 edge pieces on a 7x7, which reduces both of these last 4 edge stages to just a standard 5x5 last 4 edges. Whilst this is a decent and overall safe method of solving the last 4 edges on big cubes, it's not necessarily the most efficient method of solving the last 4 edges. Solving the last 4 edges more efficiently on the 6x6 and 7x7 generally requires a more freestyle approach. I'm going to start off by talking about the 6x6, and there are a variety of different cases when you get to the last 4 edges on the 6x6, which can essentially just be solved in one algorithm. And these are the sorts of things you need to look out for, because my general rule of thumb is if you see something on the 6x6 or in rarer cases on the 7x7, which can be solved in just one algorithm, then I would say go ahead and do it, because that will completely solve one edge for you and it's one less thing to worry about. So I said this would be kind of like a toolkit, and I'm just going to show you a variety of different cases where we can solve this white and green edge in one algorithm. And these first few cases are where we have these 2 inner wings already paired up together. So this is just a simple standard 5x5 case where we just slice, flip, and slice back. Similarly, if we have a block like this and this one over here, we can just slice, flip, and slice back. And finally, the last really easy one alg solution for this white and green edge is if we have 2 wings like this and these 2 like this, where we can just bring them down. So it's kind of like an M prime, U2, M, like that. There are some other very easy one alg cases where we don't have these inner wings paired up, and this is the first one. So we just have this block here and this block here. So we can just slice, flip, and slice back. This second one here is where we have the 2 outer wings connected, and we have this inner wing which is oriented incorrectly with respect to these 2, so this one belongs here, and we have this one over here. We can just slice, flip, and slice back like that. If we have something like this where we have 3 of the 4 edge pieces solved and we have this one over here, we can just slice this direction, flip this one in place, and then slice back to solve. And another really easy one alg solution is where we have these 2 and these 2 set up like this. So we have one outer and one inner wing connected to one another, but they are not right next to each other, like so. And it's just a matter of slicing this layer and slicing that layer, flipping it in place, and then restoring your centers. So these are the sorts of things that will come up and that you need to use in your 6x6 last 4 edge solving in order to make your solves more efficient. They won't necessarily come up every single solve, so it's decent to have kind of a default setting of, solving the inners and then the outers. But where these cases do come up, and they will come up quite frequently, it's definitely, much faster to do them first. A similar sort of principle applies for solving the 7x7 last 4 edges. However, because there are 5 edges in every group, then there are going to be far less instances where you can just solve an entire edge using one algorithm. They will come up, but they will be a bit more rare. So the thing to look out for when taking a more freestyle approach on the 7x7 is where you can solve an entire edge potentially very easily just using 2 algorithms. So instead of necessarily solving these inner 3 right away, if we have, say, a group of edges, for example, like this, where we have 1, 2, and 3 of these orange and green edges, then we can potentially use that to help us build an edge in a more freestyle approach. So, for example, if we have this one, and this one, and the middle edge is over here, we can kind of just do an M prime U2 M movement. So bring these 2 down, do a U2, and bring them back up to attach this to those ones. And that was only kind of 3 moves or 5 moves if you're looking at actual turns. And now we have a group of 4 entire edges together. So all that will be required to finish this off will be a kind of a slice, flip, slice. So we've got this last one over here, slice, flip it in place, and then slice back. And that was 2 very quick algorithms to solve an entire edge. I think a good general rule of thumb for intermediate cubers is if you have 3 edges of a 5-edge group already solved, so in a case like this, or like the previous example, then it's probably a good idea to focus on that edge. So here's just another random example, and these are the sorts of things you can experiment with and you'll get familiar with as you practice more 7x7. But looking at these 3, the other 2 edges are down here, so this one and this one. So all that needs to be done to, I guess, pair them up would be a slice move and then a slice move. However, we need something to replace it with. So we can take out this back edge, which isn't being used, by doing an R'(U)R, then do slice, slice, take it out, and then slice back. However, like I said, these sorts of things won't always occur, and like we can see here, there's not very much that's very useful to us at all. So what I would go on to do after solving that edge for the last 3 edges is honestly just to go ahead and solve the inners and then the outers. That can be kind of your default safe solving approach for the last 4 edges. One thing to keep in mind, both on the 6x6 and the 7x7, is when you're doing a slice, flip, slice kind of algorithm, you can do that in a number of different ways. So you can slice with a wide move, or you can slice with an inner move, and things like that. So it's important to kind of determine which is best for the given scenario. So let's say we're solving these inners on the 7x7, so solving the inner 3 edges, and we have a situation like this, which just requires a slice, flip, slice to solve this red and green. However, we see that this outer wing of the red and green is up here. So if we were to do a slice and then flip and then slice back, this one would get taken to this position. So what we can do instead is just do this single slice move, so this inner slice, so that when we flip this in place, this one doesn't get taken over here and actually gets preserved with these other 3 red and greens, and we can kind of that makes our look ahead job a little bit easier, because we know that we're going to have these 4, so we can, whilst we're doing that, look around and find this one and then go ahead and solve it as well. Something that I'll talk about a bit more in the advanced modules is cycling, and this is something that we can do to avoid excessive use of slice, flip, slice moves. So for example here, if we have these 4 and this one, kind of what we want to do is pair it up and then solve it in some manner. And one solution would be to flip this in place, slice across, flip, and slice back, which does keep our last 2 edges around this E slice. However, I guess a much more efficient way of handling this is just to put this unsolved edge up into the top, slice, replace, and then slice back. So the first part of cycling is to create more efficient solutions and avoid slice, flip, slice moves. But the second part of cycling is actually influencing future edges within your last 4 edge stage. So let's say we have a case like this, and we're down to the last 3 edges on 6x6, and we have nothing good there, nothing good there, and nothing good there. What we can kind of do is, let's say we have this one back here, and take it out to the top. And if we want to solve all of our inner edges, so these inner wings, in one go, then we can definitely do this by using cycling. So as opposed to putting these 2 directly opposite to one another, slice, flip, slice, just to solve these, what we can do is slice to create this block, and then insert this edge in a way such that these inners, so this green and orange, and this blue and red, and this blue and red get paired up together. So we can do that by doing F, R prime, F prime, R. And when we do that, when we slice back, we've now created these inner blocks, and all that's left to do is kind of a last 3 edge 5x5 stage.